right, good morning. So, what you did yesterday was you looked at the gene regulation activity and you were able to see how all four of your cells, 3 or 4 of your cells, had the same chromosomes. You all had a chromosome 2 and you all had a chromosome 11, and they all had the same genes on them. But what you noticed that was different, hopefully, was that you had different silver binding clips on different genes, and those silver binding clips represent permanent repression of the gene. Like those genes will never get turned on. Versus when you were then doing the cell events, you saw that sometimes a gene would get activated, you'd add a green paper clip, and then sometimes it would get removed, that you would take it off. Or sometimes it would get repressed and you'd put a red paper clip on there, which would mean that it was temporarily blocked. But then sometimes those red paper clips would come off, which means that it's not being activated, but it could be copied if the transcription factors got there. It's not blocked, but it's also not turned on. It's available just based on chance. Where when you put the green paper clip on there, it gets copied more and more translation happens, transcription and then translation. So that was kind of the point of what I hope you were seeing, or that you understood from adding the 8 paper clips and things to those clips. What you're going to work on today is the data analysis, the explanation, and then the application. So hopefully you answer questions 8 and 9 in class, where you were looking at how genes were expressed by the green paper clips or repressed by the red paper clips and then the silver binder clips. Again, remember the silver binder clips are permanent. You never took those off, versus the red paper clips could go on and off. So those were either on or off, depending on the cellular event. So you took a picture of the chromosomes. If you did not, please email someone in your group, because I know that pictures were taken of each of the cells. What you'll then do is take a look at those, and based on that, you'll answer these questions 10 and 11, thinking about what's happening with the other clips that are on there, and then answer these final questions kind of explaining what was happening. Again, you should have seen that all 4 cells had the same chromosomes, they have the same genes, but there's different expression, meaning that some have permanent blocks on some genes, some have temporary blocks, and some have temporary activators, and some it's what makes the gene special. Okay, it's what allows a cell to do its job. So you'll answer the rest of these questions, kind of thinking about the cell mechanisms, which were the event cards that caused the different short-term changes. And so thinking about what were some of the things that you read, what were some of the things that happened in your cell. And then there's a couple of examples down here that you may or may not have read about. And so just to kind of review kind of what's going on here, the first part is you're going to highlight in yellow what the cellular event was, and then you're going to highlight in green what happened. Okay, so in this case, the smooth muscle cell is growing, is the cellular event, and it has to produce actin. So an activator to the actin gene is added to the smooth muscle cell, and so then actin is produced. So this is what happens because the smooth muscle cell is going to grow. So that you're going to do that with these 2 examples here, the one about milk and the small intestine, and then one about having a lot of carbohydrates in your last meal. The final thing is there's a video here to watch about Barbara McClintock, and she studied corn and genes that are referred to as jumping genes, and you'll get to introduced to her and some of the work that she did and why she did what she did. So that's what you'll finish up today. Let me know by email if you have questions or get stuck, and I hope you have a great day, and I'll see you the next time in class.